proportional relationship, so I want you to box off inversely. Box off inversely. You're going to be able to identify directly proportional and inversely proportional from a graph. That's your learning target. And a table. So from a graph and table, you're going to be able to identify if it's directly proportional or inversely proportional. Graphs are always easy. For directly proportional graphs, they always go through the center. So if I say which one is directly proportional, it's whatever goes through the center. Inversely proportional looks kind of cool. They never cross zero. The graph will never cross that zero. So it's the opposite. This goes through zero. Inverse doesn't even touch zero. The reason for that, if you look at the equations directly, y equals something times x. Y equals kx. So maybe double that. That's the equation you're going to use today. And you used it already yesterday. Inverse is y equals something divided by x. Can you ever divide by 0? Have you ever asked Siri what's 0 divided by 0? You can never divide by 0. It's undefined. If you don't believe me, go ahead and punch it into your calculator a bunch of times. If I go 5 divided by 0, my calculator is going to be crabby at me. It's going to say divide by 0, error. 0 can never be on the bottom. So notice if it says y equals something divided by x, then that x can never be 0 because it's undefined. So that's why it never goes through this center point. Okay? So 2 equations you're going to work with today. Y equals kx, y equals k divided by x. That's what you're going to work with. Okay, so let's see. We're just going to identify here if they are directly proportional or inversely proportional. Is this graph number 1 here, directly or inversely proportional? Why is it direct? Yes, it's as easy as that. You're checking to see, does it go through 0? If it goes through 0, it's direct. What about this graph number 2 here? Inverse, because it doesn't go through 0. Well, I can't say that because this is not inverse. Inverse is kind of that curved looking line. So I don't want to define it as it doesn't go through 0. It's a curved looking line that looks weird. What about this next one? Direct or inversely? Or inverse? Inverse. And why is it inverse? Because it looks weird. It doesn't go through 0. Right? What about the next one? And why is it direct? Whoa. Direct, it goes through the origin, goes through 0. Next one? Direct. Goes through 0, direct. Next one? Inverse. Why is it inverse? Yeah, because it kind of curves around 0. It avoids 0 at all costs. So, main learning target right here, if I give you a graph, can you tell me if it's directly proportional or inversely? Yes or no? Yes. Okay. So pretty much what I look for, is it going right through the center, or is it going like curved and never touching the center? That's what I look for. Okay, next. Now you're going to have to identify from tables. That's where it gets a little complicated. Proportional, we've already worked on. Proportional, the ratio of y to x is constant. Ratio, y over x. Inverse, it's the product of y and x is constant. So that means y times x. So, if they're proportional, this is directly proportional. If they're directly proportional, the ratio is the same. If they're inversely proportional, the product is the same. Then you have to make an equation like you did earlier. So, under here, I would write y equals kx. That's the equation for directly. So you write it down. Inverse is k divided by x. I want to just use algebra to define why this is. If you think about this, this is k times x. Solving an algebra equation is always doing the inverse operation. For example, what's the inverse of plussing for? Subtracting. It's like that opposite, isn't it? So the inverse of timesing by x is dividing by x. That's where we're getting this from. It's applying that algebra concept. Okay, so let's analyze this table. I'm going to check the ratio. 4 over 1. Is 4 over 1 the same as 8 over 2?
Yeah.
Is it the same as 12 over 3? Yes or no?
Yeah.
Okay, so then this is directly, so I'm going to say direct. And my equation is y equals 4x, or 4 over 1x. I don't ever put that 1 on the bottom. I don't really check ratios first because I can divide easier than I can compare a ratio. Or I can multiply easier than I can compare a ratio. I usually check the product first. What's 3 times 20? 60. What's 6 times 10? 12 times 5? Okay, so this is inversely proportional. And my k, so you need to know what my k is. My k is equal to whatever that common product is. My k is equal here to whatever that common ratio is. K is the comparison. It's what the common theme is between y and x, okay? K is always whatever that common theme is. So I would say y equals 60 divided by x. Now notice, what I'm doing is utilizing this formula and then the relationship given. This 4 came from the relationship I had throughout, okay? This 60 came from the relationship I had throughout. Okay, again, next table, I always check product first because I can multiply faster than comparing ratios. What's 6 times 3? 18. What's 8 times 4? 32, not inverse. So now I have to check my ratio. Is 6 over 3 the same as 8 over 4? Well, 2 over 1. 2 over 1. So, and then I just check 2 over 1, 2 over 1, 2 over 1, all throughout. So this is directly proportional because the ratio is the same. And my equation would be y equals 2x, or 2 over 1x. Okay, again, I check my product first. What's 1 times 8? 2 times 4? 8. 8. 16 times a half is 8. Since the product is the same, it's inverse. So I know this is inversely proportional. So y equals k over x. K is whatever that common theme is. What's our common theme? 8. 8 over x. Do you love or hate this? No, don't hate actually. Do you love or love it? Do you love it or love it? That's what I want you to do. I need you to love it.
I love it.
Check product first. What's 25 times 2? 10 times 5? Is it 50 all the way out? Okay, so which one is that, direct or inverse? Inverse. So inverse means k over x. And that's per my notes. I would be referencing my notes. What's my k? What's the common theme? 50 over x. So identify from a graph, identify from a table, and make an equation. That's what I want you to be able to do today.